I'm Anil Kumar. Welcome to my series on calculus. We'll actually discuss how to find area under the curve with the help of a unique example. Unique in the sense that it comes from, again, one of our subscribers. So, Mr. Arif, thanks a lot for sharing this example with us. And I love the statement that you searched the whole internet, couldn't find any video, even close to your question. I actually appreciate your trust in me, and here is the solution. Since you also mentioned that you missed the class, that means I need to give you some background before really getting down to the solution. And therefore, I'll begin with some very basic concepts, and I'll split the question into few parts as you can see here, and then solve it. So that way, many of our viewers and subscribers will understand the whole concept and will be in a good position to solve similar questions. There were many requests about the pens I use, so I have displayed these pens here. I hope you can see them. They're pretty good pens, right? So these are two key pens which I use, one blue and one black, and I love colors and freehand sketching, for which I just buy the cheapest available in the market, right? So there's nothing very specific about it. However, these are my good pens. Now let's try to understand what the question is and how are we going to solve it. Okay, your question was basically this. Find area under the curve f of x equals to 3x minus x squared over this interval. This is your question. Using limits, right? Let me write here, using limits. Right? Okay. Now, we could actually use integrals and get the solution in no time. I'll take that also as a part of this later, as a different video. But this is using limits, right? Now, what I did here is split the question into many parts. Let's try to understand how are we going to solve it, and then we will actually solve. The function given to us is 3x minus x squared. So let me sketch the function here first. So as usual, we'll always make rough sketches here, which are very meaningful and practical, right? The function is f of x equals to, I can take x common just to factor and show you how to graph it, minus, right? So minus x squared means this thing goes downwards, right? Okay. So now it's a parabola which definitely has two x-intercepts, one at 0, one at 3. So we could expect this to go like this. So that's your parabola. Now, we want area of the curve between the interval 2 to 5. We know this point is 0 for us, this point is 3, and somewhere here we'll have 5. Let's say this is 5 for us. Okay. So let's say 2 is somewhere here. So when we want to find the area under the curve, then you know by our calculations this will be positive. However, the other area which we will calculate will be negative. But as you know, area is always positive, correct? So we have to do negative of this and add to get the total area. Is that clear to you? So that is the first thing which we need to understand. Now, as the very first example for you, Mr. Arif, straight away going from 2 to 5 will be very confusing. And therefore, what I've done here is that we'll go in small steps. In step number 1, we'll actually find the area from 0 to 3, right? Working from origin to the point is always very simple. So we'll first find the area of the whole positive part of this curve. You get the idea. 0 to 3, right? So what we'll do here is that first we'll find area, we'll say A1, which will be in the interval 0 to 3. And then we'll find A2, which will be in the interval 0 to 2. So when we do all this, you will actually understand the process, correct? So, and then what we will do here is that we'll find from these calculations, we'll find A3, which will be difference of A1 and A2, right? So A3 will be this area for us. Perfect. The green area, which we need. Now, we'll again find area, let's say A5, which will be from 0 to 5. Right? Then what we are going to do is we'll find area A4, which is going to be area A5, right, minus area A3. So when I do that, I get this area, which is A4. And this area will be negative, right? This area will be negative as shown here. Then finally, we'll get our answer, area equals to what? We'll add the area A3 with absolute value of A4. You understand, areas are always positive. So when we use the term area, there is no harm in writing it like this, absolute value, right? Make it positive and then add it up. So once you do that addition, you get the actual area you're looking for between 2 to 5. Is that clear to you? So a lot of time we are going to do the same calculation, I should say similar calculation, with minor variation in numbers, which could be 2, 3 or 5. Perfect. But the whole idea is you will understand the concept, right? Once we have done in this fashion, then we'll also reattempt this question using integrals and also directly using the values, right? So that will be the second part. While we solve all this, we need these formulas. So we have to sum the basic areas. I'll get to the sum also, the basic concept. But we'll need these formulas. Now these are standard formulas which are known to most of the students. If not, you have to apply them, right? So remember or keep them as a reference. Sum of natural numbers is n times n plus 1 over 2. Sum of squares of natural numbers is 1 times n plus 1 times 2n plus 1. And sum of cubes is n times n plus 1 over 2, right? So that is how we get sum of these numbers, right? So we are talking about n belonging to natural numbers, right? Non-negative integers, you can say, right? Okay. So these are the formulas. Now here is one more concept which we should touch upon before getting into the solution. And this is huge. Hats off to the scientists. The Riemann sum, by his name this is called. Concept of finding area under limits, concept of finding area using limits, and its relation with Riemann sum. That is what we are going to consider now. So the foundation of using limits is kind of like this. Let us say we have this interval from 0 to 2. We are going to divide this into small portions, equally spaced. Do you see that part? So we are going to divide this into small portions which are equally spaced. We are saying that these portions are n in number. So what we have here is, let's get to the concept. So the concept is like this. The interval is divided into n equally spaced intervals. So in general, if I have from A to B, let us say, so let me just talk about it in general, and then we'll explain in specific to this example, okay? So let us say we have a curve here, right? So let's say some other curve, okay? Now we want area from one place to another, and let us say this is our axis, right? Let's say this is A for us and this is B. So what we are trying to do here is that we are dividing the whole interval, which is definitely B minus A, right? So we have here B minus A as our interval. We'll divide this into n equal parts. So in that case, what we are going to get is, out of these n equal parts, when we divide, we could actually, let me share with you, let's say these are the n equal parts, right? Okay, so we form rectangles. Okay, so we will form rectangles. So these area of the rectangle approaches the area under the curve provided n is very large. You get my idea, right? So basically what we are going to do here is we are going to add all of them, and that is where the summation and limit comes together. Perfect. So the concept here is to sum. This is the summation sign, right? In general, we can say this is a point xi, and if we are taking end point of our rectangle as a reference, then this will be x1, that will be xn, correct? So I moves from 1 to n of the function times delta x, where delta x is equal to b minus a over n. So b minus a over n is the width of each rectangle, and the height is f of x, right? Right? So any rectangle which we have taken here will have a width of delta x and a height of f of x. So if I say xi, any general where I spreads from 1 to n, since we are taking the endpoints, in that case xi, f of xi will be the height of this rectangle, which will remain constant, delta x, which is basically difference of these two limits divided by n. And the formula gives you area of a rectangle, width into height, right? Length into width. Adding all these rectangle areas will give us a total area, provided n is approaching infinity. So we write here limit n approaches infinity. Does it make sense to you? So that becomes, they become very, very small and compact and exactly match the curve. Otherwise, an approximation, and this method is Riemann's sum. Now, Riemann's sum necessarily will not give you area. In this case, we may not get the complete area, but difference of area, sure. Right? To find the area, we have to do what we were discussing, make negative of what it was, and then add it up. Right? So that's a brief note on the concept, and now let us begin and answer the question. So let us begin with area under the curve f of x equals to 3x minus x squared over the interval 0 to 3, both included, right? So let me just make a rough sketch of what we are trying to do, and then we'll solve this question. So what we have here is a parabola which has two x-intercepts, one at 0, the other one is at 3, upside down, kind of like this. In this part, we are trying to figure out the area under the curve from 0 to 3. So this area. Now these points for us are 0 and 3. To find the area, we'll first divide this interval into n equal parts, right? So we are divide in n equal parts. to get the width delta x as 3 minus 0 over n, which is 3 over n. So every part of this, which we are calling as our rectangles, will be, let me make a bigger one here, right? So every rectangle here will have a width which is delta x, correct? So that is the width of our rectangle. Now, we could take any point on this rectangle to find the height of the rectangle. What we are doing now is taking the end point. So we are using end point. So let's call this as I, right? So in general, we are calling this as xi, which is the end point. So the value, the function at xi gives you the height, and therefore the area is going to be f of xi times delta x. Is that clear to you, right? So that much is f of xi, correct? Now we need to find an expression for xi, and then we'll add all these areas. How do we figure this out? Okay, so from here we know the value of the function at 0 will be zeros anyway. We are spacing them away at a distance of delta x. So x1 will be delta x away, which is 3 over n. x2 will be 2 times this second rectangle, right? So 6 over n. x3 will be 9 over n, correct? Then xi should be 3 times I over n away. So we get the general expression for xi. You see how? Perfect. So what is f of xi for you? F of xi is 3 xi minus xi square, right? You could always replace this with 3i over n. So you get this expression as 3 times 3i over n minus 3i over n whole square. So that becomes your f of xi. Is that clear to you? Since xi is 3i over n, right? Now, what is the area? Area is product of f of xi times delta x, which means 3 times 3i over n minus 3i over n whole square times delta x. So that becomes the area of this particular rectangle, right? Of one rectangle, of general rectangle. The concept here is to add all these rectangles. So we denote it by writing this summation sign. Is that clear to you? So we are going to sum all these rectangles. How many of them? I values varying from 1 to n. We are taking the end points, right? So the first rectangle x1, then xn, okay, of the function times delta x. And that is our function, right? Where delta x I should have written as 3 over n, but now I'm going to write it. So we get here as 3 times 3i over n. I'm multiplying each by delta x times delta x, which is 3 over n, minus the second term, which is 3i over n whole square times 3 over n. Delta x is 3 over n, so I multiplied individually both. We get our sum. Now, if n is very large, then this area is actually area under the curve, and there is the limit. So the limit, n approaching infinity. You understand now the concept. So that is how the limit helps us to find the area under the curve for the given situation. Perfect. So now We could write this as area under the curve from 0 to 3 as all this. We'll say limit n approaches infinity, and the sum being from I equals to 1 to n of, let's multiply these. So I and other things are independent of I. So they are 3 times 3 times 3, which is 27 over n square. And what we get here is I minus. In this case, square 3 is 9. 9 times 3 is again 27. And square and n means n cube. And we have I square here. So this is the expression which we get now to work with. Well, sum of integers, where integers are from 1 to n, we have a formula. Sum of natural numbers, sum of squares of natural, we have a formula, correct? We are going to use that formula now. So we get here limit n approaches infinity, and what do we get here? We'll sum this up. So we get 27 over n square, and the formula for I is what? Let me use a different ink here. N times n plus 1 over 2. Now this is the formula for this, correct? Which we shared with you right in the very beginning. So you definitely need to know these formulas to further move on. This is for sum of natural numbers, that is for sum of squares. Clear? Now, the other expression here is minus 27 over n cube, and the sum of squares is what? The sum of squares is n times n plus 1 times 2n plus 1 divided by 6. So these are the two formulas which we will use, and that is sigma of I. Do you understand these two formulas now? Sigma of I and sigma of I square are these two formulas. Correct? Now let's continue. So we have limit n approaches infinity, and we can simplify this a bit. Well, 27 over 2, let's write like this. Let's write like this. I'm trying to make it simple for you, taking some time, of course. And now, let's open this bracket. So we have, let me show you this math in different color, right? So n square plus n, we open this bracket, divided by n square. Is it clear to you? Now the rest of the thing here is minus 27 over n cube. We'll write 6 here, okay. And well, n cube, one of them will cancel, so we get n square now, okay. So we could write this as, let me open this. So n times 2n will give you 2n square, right? N times 1 plus n, and 1 times 2n plus 1 over n square. So what I did in this step was, I took all of the terms independent of n on one side, so those are the numbers to work with, and here I got those n's, right? Okay. Now, so in this case, you see it is limit n approaches infinity. Within bracket, we have 27 over 2. We get 1 plus 1 over n. Do you see that? 1 plus 1 over n, right? Here we have minus 27 over 6. And when you divide n squared by this, you get 2. And this is 3n. 3n divided by n squared will be 3 over n. And here it will be 1 over n square. Perfect. Now, if n is approaching infinitely large number, these values approach 0. So what are you left with? So when we apply the limit, n approaches infinitely large numbers, we get 27 over 2 times 1, which is 27 over 2. And here we get minus 27 times 2 over 6. 27 times 2 over 6. Do you see that? That's what we get, right? So you could simplify this and get your answer. So now we could actually simplify this. Let me rewrite this. 27 over 2 minus 27 over 3. So we get 6 as common denominator, and 3 times 27 minus 2 times 27 will give us 27. You can now divide by 3. 3 times 9 over 2. So the area in this curve is 9 over 2, or 4.5 units square. So what you find here is that the area is basically equals to 9 over 2 units square. Is that clear to you? Right? So these are not so difficult calculations if done like this. Now what we have done here is found the area between 0 to 3. In the next exercise, you should do it on yourself, 0 to 2. And then we'll do some more operations to get to our final result. However, I hope by this time you've understood the whole concept. So I'd like you to repeat this concept and solve the whole question. And then I'm going to upload the later half of this video. I hope you understand and appreciate it. We might have a break now. Let's take a break and see some wildlife all around us. Thank you. So I hope you enjoyed the break. It was a lovely sight. It's very rare to find coyote, and I was just lucky to see one. I also hope you've understood this process of finding area under the curve using these rectangles. Now, once again, let's repeat this process to find area under the curve from 0 to 2, and we'll take away that from 0 to 3 to get the area between 2 and 3, right? So we'll actually follow exactly the same steps. So let me again sketch here a much smaller diagram this time. It's a parabola which is going through the origin. We are actually interested in the portion which is from 2 to 3, right? So let's say this point is 2 for us. We know this is 0 and that is 3. We want to find area of this portion. Correct? So in the previous part of our video, we have already seen that for this particular function, the area of this curve, which is 3x minus x squared, when x is from 0 to 3, was 9 by 2. So the area was 9 by 2, right? So from here to here, we found that the area was 9 by 2. Correct? So we know what is this area. This area was calculated as 9 by 2. Correct. Now what are we going to do is apply the strategy and find the area which is from 0 to 2. So we'll find now this particular area. The idea is to take away from the whole the area from 0 to 2. Perfect. So our question now will be, we'll consider the same function which is 3x minus x squared. To find area between 2 and 3, we'll actually first find area between 0 and 2, right? So let's call this area as A1 for us, right? And then we'll take away this A1 area from the total to get this area. Is that clear to you? Okay, so 0 to 2, we will divide it into n equal parts. So delta x will be 2 minus 0 divided by n. So we have 2 over n. The value for each rectangle will be x1, x2, x3 till xn. First one will be 2 over n away. Second one will be 2 times 2 over n, or I can write 2 square over n. And then third will be 2 times this number, right? So which will be 2 cube, or 2 times 3, right? So what will it be? So first is 2 over n, second is 2 times 2, right? I should not have written 2 square. Then it will be 3 times 2, right? I should have written 3 times 2 over n. And this fashion, if we continue, then general will be I times 2 over n, correct? 2 over n. That would be my position. So we're looking into the area, which is what? So the area, let me write straight away the area under the curve from 0 to 2. So we say area will be sum of these rectangle areas, correct? So which is sigma. Area of each rectangle whose width will be delta x, and the value will be f of xi, right? So f of xi times delta x, where the value of I will change from 1 to n. And if n is very large, that is limit n approaches infinity, then we get the fair approximation of area under the curve between 0 to 2, correct? Now, we could now write down, we know all these things, so we know this is basically f of xi, we have to substitute xi here, right? So we get 3 times xi minus xi square, right? And we have to multiply all this by delta x. Substituting these values, which we just calculated, we know this is limit n approaches infinity, I equals to 1 to n. Now, when I say 3xi this, then xi for us is 2i over n, right? So we'll write this as 3 times 2i over n, that is the value of xi, right? Minus 2i over n whole square. All this being multiplied by delta x, which is 2 over n. Correct? Now, let's take it inside, and then what do we get? We get limit n approaches infinity, sum of i's from 1 to n. So when you multiply here, you get 2 times 2, 4, 4 times 3, 12, right? So we're multiplying 2 over n with all this. So we get 2 times 2, 4 times 3, 12 over n square times I, right? Minus. Here it is 4, 2 square is 4. 4 times 2 is 8 over n cube. The square times 1 times I square, correct? Now, these terms are independent of I. We are doing sum of all the i's from 1 to n. So we're going to use the formula here. Sum of natural numbers, correct? Sum of natural numbers, right? So we get this as 12 over n square times sum of natural numbers. Now I think we remember, which is this, correct? Minus 8 over n cube, sum of squares. Well, sum of squares is n times n plus 1 times 2n plus 1 over 6. Correct? Okay. So that's what we get. Now we can actually simplify this and get the result. Okay. So we could write this as limit n approaches infinitely large value. So we get here, now when you do 12 by 2 is 6, When you divide with n square, what do you get here, right? So this is n square plus n, we get 1 plus 1 over n here. Is that clear? Just as we did last time. Here, dividing 8 by 6, we get what? Well, let me write, we'll get 2 from there also. Anyway, let me write 8 by 6 here. And here, one of the n's get cancelled, right? So what we get here is, let me expand all the numerator terms, n being cancelled. Then we have 2n square plus n and 2n, which makes it 3n plus 1, right? Divided by n square. Clear? Now, as n approaches infinitely large number, 1 over n becomes 0. So we get here 6 minus 8 over 6. Now this n cancels with this, so you get 2 here, right? So this approaches the value 2. So that is what you get. Got it? Right? So you could reduce this to 6 minus 8 over 3, which is how much? 18 minus 8, which is 10 over 3. Correct? So this area we found as 10 over 3. Perfect? So we say that A1, that is from 0 to 2, the area is 10 over 3. Now let me see what is the area between 2 to 3 now. What is the area here? So let's call this as A1, and we are calling that area as A3. So the area A3, let me just add this here, will be equal to the earlier area, which was 9 over 2, this area 9 over 2, minus what we found, which is 10 over 3. Correct? So that becomes the area of the portion between 2 and 3, right? So for the function, the area under the curve when x is from 2 to 3 is that, correct? Which is equal to 6. 9 times 3, 27 minus 20, or 7 over 6. Correct? So area under the curve is basically equal to 7 over 6 from 2 to 3. So this area here is 7 over 6. Is that clear to you? Correct? So that is how we're going to find. So this is an easier approach. Rather than going straight from 2 to 3, this becomes simpler to begin with. We'll take up another example where we'll do direct from 2 to 3. Okay? So I hope that makes sense. Let's continue our question. And now, let's see how to find the area of the curve between 3 and 5. Right? So that's the next stage. So now, we'll continue with our question. We'll find area of this curve under the interval 3 to 5. So again, the same curve. Now, the portion of the curve which we are interested in is between 3 and 5. So it's kind of like this, right? We have worked on the first half of this portion, which is, we know now that the area between 0, 2 and 3, that is known to us, right? Now let us say this is the point 5 for us. We are now interested in finding this area. So how can you find this area? Well, what we really know that the area of this function f of x, which is 3x minus x squared, when the interval is from 0 to 3, is 9 by 2, correct? So what we are going to do now is to find area A5. We'll find this area of the function of 3x minus x squared in the interval from x to 5, from 0 to 5, right? So we'll do the whole area. So we'll try to find this area. Now this area will be the first area, which is, we're calling this as A1, right? Now, A5 will be what? A5 will be sum of A1 and minus A2. Do you understand? So A5 is from 0 to 5. So this area, let's say, this area, let's call this area as A4, right? Then A5 is going to be equal to A1 minus A4. So we'll find A4 by taking away big area minus the small area, right? So big area will be actually smaller since this is a negative value, right? So I hope you understand the concept. So let's begin. So exactly same steps. Now the only thing is we are finding area of the curve from 0 to 5. This actually gives you difference in these two areas, right? So as you can see, 0 to 3 area minus that area, that is negative, right? So it is a difference between these two areas. Correct? Okay. So let's see how to find this. Well, same standard method. So delta x is what? Now we are going to divide 5 into equal parts. So 5 minus 0 over n gives us 5 over n. And each point x1 is going to be 5 over n. x2 will be 2 times 5 over n, right? x3 will be 3 times 5 over n. So xi is going to be 5i over n, right? So the area under the curve will be, so A5 is the area which we are talking about, will be limit when n approaches infinitely large value of sum of all these areas, which are areas of fxi times delta x. Correct? Delta x is constant. Now, in our case, it is going to be limit n approaches infinitely large, sum of xi is 5i over n. We'll substitute x for xi. So what we'll get here is 3 times 5i over n, right? Minus x square, which is 5i over n whole square. Now everything has to be multiplied by delta x, which is 5 over n. There you go. That becomes your formula. Now just as we did last time, same procedure. So I hope by the end of this video, you will exactly remember how to go about for such questions. Remember, there is none on internet like this. Right? So this limit is from 1 to n for I. Is it okay? Okay. So let's bring it in. So what we get here is 5 times 3, 15, right? Times 5, 75. So we get 75 I over n minus, this is 5 cube, 125 over n square times I square. Perfect. Now, as you know, this could be written as limit n approaches infinitely large value. Now, when I say sum of I, sum of natural numbers, we get what? 75 over n times n plus n times n plus 1, right? Divided by 2. N times n plus 1 divided by 2. Okay. So that is the first part, minus 125 over n square times n plus 1 times 2n plus 1 divided by 6. Right? So all this you get. Now you can simplify it, right? So when you simplify, these n's cancel, this one of them cancel, correct? This was n cube, I'm sorry. So this was n cube, one of them cancel, we get n square. So we are left with n square. Okay, we'll write it now. So what we get here is limit n approaches infinity. So we have already done the sum. Now let's calculate this out. So we get 75 over 2 dividing by n. N times n was n squared. So one of the n cancelled. We have n squared. Right? This is n cubed because we multiplied by 5 over n. Right? So I forgot to multiply them both by n. Okay. So we get times, divide them by n, we get 1 plus 1 over n. Clear? Minus, here we have 125 over 6, and there we get, multiplying by n's, we get 2n squared plus 3n plus 1 divided by n squared, right? So when n is very large, these two quantities become 0. That also becomes 0. So what you get here is 75 over 2 minus 125. Here you get 2, right? So 125 over 6 times 2. This is equal to how much? Let's calculate. All right? So we get 75 divided by 2 equals 2, and from there we'll take away 125 divided by 3. So we get minus 25 over 6. You get the idea. So this area looks small here, but it's actually a huge area, right? So the net result is a negative 25 by 6. Correct? So that negative 25 by 6 clearly indicates what? So that's the area from 0 to 5, correct? So the area from 3 to 5 should be how much? The area from 0 to 5, right? The total area minus the area from 0 to 3, correct? So we should do that, correct? Let's write negative outside. So we'll do 25 over 6 minus 9 over 2. Also, negative of, you have to add them up within the brackets, right? So then you get this area, which is the area of the portion between 3 to 5, right? So when you add this up, what do you get? So you get negative because it's going downwards. That's why it is negative. And you can take a common denominator of 6, and you get 25 plus 3 times 9, 27, correct? And you can add them up to get your right answer, right? So which is negative of 7 and 5, 12, 52 over 6. So that is what we get as the area of between 3 to 5. Is that clear to you? Now we have all the areas worked out, right? So when we are talking about adding the areas, we have to make absolute value, right? So we have absolute value of area between 3 to 5 is what? Positive value of 52 over 6, correct? So, or you could write this as half of this, which is 26 over 3, right? So that is the absolute value of this. Now, knowing all that, we are now in a good position to answer our question. That is, we need to figure out area under the curve between the interval from 2 to 5, right? So let's summarize what we just did. So a bigger diagram this time. So what we have here is that we are interested in the area between this portion, right? This is 0 for us, that is 2, this is 3, and somewhere here we have 5. Correct. We found that this particular area is, we'll call this as area A5. So area between 3 to 5 was 26 over 3. We are talking about absolute value, right? So we're talking about absolute value. since we have to add them up, right? Now, the absolute value of area between 2 to 3 was 7 over 6, correct? So the total area was, say, between 2 to 5 is addition of these two. 26 over 3 plus 7 over 6. Is that clear to you, right? So which is, 52 over 6 plus 7 over 6, which is 59 over 6 unit square. So that is how we are going to figure this out. So I hope the steps are absolutely clear, right? So we actually did each and every area from 0 to 3, 0 to 2, 0 to 5. We actually split this. We actually reflected this to make it positive, to add them up and get a result which was 59 over 6. So we can now say that this area under the curve over the interval 2 to 6 is 59 over 6, correct? Which is approximately 59 divided by 6 is 9.83 unit square. Perfect. So that is how this question will be solved. I hope you understand and appreciate all the steps. Now in another video, we'll see how to do it directly from 2 to 5. Remember, there is a 0 at 3 and between 3 to 5 it is negative. Areas are always positive, so we have to add the absolute values, right? So a note here, add absolute values to find area, total area. Is it clear to you? So that is how we are going to do it. I hope it makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.